press pause and answer the question.
All right, so now we're looking at data. Here we have parts per million of CO2 levels, carbon dioxide levels in the atmosphere, and here we have time in year. And so we see that the parts per million in the atmosphere goes up and goes down and goes up and goes down, and seems to do it on a yearly basis or an annual basis. It goes up and down. And you likely know that that's because there are more trees in the northern hemisphere to absorb carbon dioxide. So when it's summer in the north, there's a different kind of atmospheric makeup than when it's summer in the south, because the total number of trees available to absorb the carbon dioxide that are actually have leaves on them, they're going to vary, right, depending on the season. But you also see the trend, and you see it going up. It's kind of a secular trend going up. And what we can do is, with the black lines here, what we're doing is we're saying, okay, we're adjusting. So we're accounting for the fact that there's more trees in the north, because there's more land area in the northern hemisphere. And once we adjust for that, this is kind of the trend of the temperature. And we see it going like this. So we see a linear relationship. And this blue line is the best fit. So it's the line that kind of, if we take the black line and we made it straight, it would look something like this. So the question is, what are we saying? According to the data from the black line, that's this one here, what relationship is well supported by this graph? And the answer is this one. There's a strong positive linear relationship between time and the amount of carbon dioxide in the atmosphere for these years, 2014 to 2018. So a strong positive linear relationship. What does that mean? What does strong mean? What does positive mean? And what does linear mean? Strong means it's pretty clear. Like, it's not all over the place where it's not totally clear that it's going up. It's pretty clear it's going up. Positive means as one value increases, the other one increases. So as year increases, the concentration of CO2 in the atmosphere also increasing. And linear means when we graph it out on a linear scale, importantly, this scale is linear, 395, 400, 405, 410. And this scale is linear, 2014, 2015, 2016, 2017, and so forth. That we can plot it out, and it's a linear relationship. It makes a line. It can sometimes be exponential or logarithmic, but still look like a line if the x or y axis is not arithmetic in its progression. If it were to go from 200 to 400 to 800 to 1600 or so forth, something may look like a line but actually be logarithmic or exponential. But in this case, we have a strong positive linear relationship.